To discuss about introduction to chromatography. Chromatography, as stated, it is a separation technique that permits separation, isolation and identification of closely related compounds in a complex mixture. Chromatographic technique was invented by Russian botanist Michael Quisset in 1906. He employed the chromatographic technique in order to separate out plant pigments such as chlorophyll, xanthophyll by passing a solution of this plant pigment into a glass column that had finely divided calcium carbonate. After performing this experiment, he observed that color bands were formed on the column. Based on this, a successful separation he had got. So this technique was later on known as chromatography. Although Quisset performed this experiment for colored components, chromatography is not restricted only to colored components, but also non-colored components. This complex term was explained by many scientists. So Kuhlmann explained this chromatographic technique as a physical method of separation of different components that are distributed between two phases. The first phase is the stationary phase, which has a larger surface area, and the other one, the second phase, is a fluid that percolates along or through the solution. Now we move on to the types and classification of chromatography. Chromatography, as I told, there is two phases involved in it: stationary phase and mobile phase or moving phase. Stationary phase may either be solid or liquid, while the moving phase will be liquid or gas. The types and classification, the types of chromatography is divided into four categories that is explained here. Type 1, the mobile phase is liquid, stationary phase is solid. The chromatography technique is known as column chromatography. In column chromatography, the adsorbent is held within a tubular column, which may be a glass, and adsorbent is finely packed. It's finely packed or tightly packed and finely distributed in that glass column. And in ion exchange chromatography, the mobile phase is liquid and stationary phase is solid. The only difference between ion exchange chromatography and column chromatography is that in column chromatography, adsorption is the basic principle in column chromatography, and chemical exchange. Rather than adsorption, it is the chemical exchange that separates. That is the principle behind ion exchange chromatography. Type 2 is paper chromatography. Mobile phase is liquid, stationary phase is liquid. We may think that paper, which means a solid, how can it be a liquid? Paper is a stationary phase, but in paper, the adsorbed water molecules that act as stationary phase. So we call in paper chromatography, the stationary phase is a liquid and mobile phase is also a liquid. In thin layer chromatography, mobile phase is liquid and stationary phase is liquid or solid. The underlying principle of thin layer chromatography is either partition or adsorption according to the stationary phase chosen. And then the other type 3 chromatography is gas solid chromatography or GSC. The mobile phase is gas and stationary phase is solid. So it is known as gas solid chromatography. In gas liquid chromatography or GLC, mobile phase is gas and stationary phase is a liquid. Thus we have come to an end of types of chromatography. And now we move on to the details of column chromatography. As we have said, a chromatographic technique involves stationary phase and mobile phase. In column chromatography, the stationary phase is a solid and mobile phase is liquid. The components present in a mixture are separated by this technique, column chromatography, in the principle that the components present in the mixture are adsorbed in different varying extents to the adsorbent. So that is the main principle behind column chromatography. If such a solution is passed through column chromatography, the components that have a greater extent of adsorption to the adsorbent get adsorbed at the upper layers of this adsorbent, and those who have lower extents of adsorptive tendency towards this adsorbent, these are retained in the lower layers. Thus, we get a series of bands or the distinct layers which have individual components in it. Here we represent an apparatus for column chromatography. This is the column, this is a glass in which we fill adsorbent. Adsorbent is finely divided, we use finely divided adsorbent. Mostly we use calcium carbonate or silica gel, etc. And then we collect the filter material at the bottom of this glass column. The solution is poured down here. So once adsorption, that solution is poured and many the components get adsorbed once, we pour a pure solvent in it so that less easily adsorbed material which are present in the upper parts of this column move on to that solvent layer and they are reabsorbed in the lower layers. Thus, partial separation of the components that we are achieving. And then, in order to give out, means to separate all these components, we pass a polar solvent. Usually we use non-polar solvent in the glass column. So we use polar solvent in order to remove all the adsorbate materials from the adsorbent. So when that polar solvent is poured into this column, the molecules that are less adsorbed, that means which are coming in the lower layers, come out first in the filter column. And then if more number of times when we are pouring the solvent, at last the strongly adsorbed materials which are seen in the upper parts come out. The adsorbent here we represent silica gel. This is called silica gel. This is used as an adsorbent in this glass column. So silica gel, we use a solvent in order to dissolve silica gel. As I told, it is a non-polar solvent like hexane or something. So in order to get the successful separation of these components, it is necessary that we choose the right adsorbent and solvent. Usually, adsorbent must be insoluble in the solvent, and it must not be too coarse or too fine, and it must have diameters 8 to 12 mm, and it should not react with the molecules present. But if as it reacts, we are not getting the component that we want. So adsorbent should not neither react or neither act as a catalyst for decomposition, rearrangement and other reactions. So adsorbent, the right choice of adsorbent is necessary, as I told you. So adsorbent, weak adsorbent is sucrose and starch, that also we can use, and intermediate adsorbents is calcium carbonate and calcium phosphate. Strong adsorbents are alumina and activated charcoal. So in order to activate alumina, we heat alumina at higher temperature and then cool in evaporated desiccator. So we get strong adsorbent such as alumina. So if strong adsorbent is used, it is very difficult to separate out the components from the adsorbed material. So usually we use some weak adsorbent or something else, and the solvent, as I told you, it is non-polar. So we can use esters of carboxylic acid, alcohols, pyridines, hexane, benzene, etc. whatever we want. And then this is all about column chromatography. Here we have explained. In blue color we have explained about component number 1, which is A, and B in brown color as component number 2. This is a separation. So at first we pour the solution that we wanted to separate out through the upper part of this column. This is called glass column. So we pour the solution. It contains, as I told you, AB solution is there, and then this is the adsorbent that is used. So it is finely fitted, it is finely divided, it is closely packed in the glass, and then the solution passes down the solution so that the strongly adsorbed material, that is B, get adsorbed in the upper layers, and the less adsorbing tendency who has the component A get adsorbed in the lower layer, or they are retained in the lower layer and B is retained in the upper layer, as it has greater tendency of adsorption towards the adsorbent that we are using. That's all. By this we have come to an end of column chromatography. Thank you.